Hello, welcome to my video series of algorithms. In this video, I would like to motivate the study of algorithms and give an overview of the contents of this video series. An algorithm refers to a set of well-defined steps for solving a problem. It could be a computational problem or a real-life problem. For example, you can develop an algorithm that solves the problem of how to get up and go to work quickly every morning. The algorithm likely contains a set of steps. For example, we can have step 1 of getting up, step 2 of washing face, step 3 of brewing coffee, and so on. Once we have developed such an algorithm, we could adapt it to our daily routine or even recommend it to our friends who struggle with the same issue. As the steps in an algorithm are well defined, it will give us more expected outcomes rather than unexpected surprises. For example, if we follow the routine and brush our teeth every morning, we can eliminate the bad surprise of having a cavity. On the other hand, since there's no morning jogging involved in the algorithm, the good surprise of making some good friends with people who often jog in the morning is also unlikely to happen. So, it doesn't matter whether it's a good surprise or bad surprise, algorithms can prevent them from happening. While it is a personal choice of whether to live a life full of surprises, we don't like surprises in the context of computer science and other fields of science and engineering. We want the computer to work as it is told to, we want the coffee machine to brew coffee as intended, and we want our understanding of the nature to be precise and comprehensive. Therefore, studying algorithm can be very important in science and engineering. There are two major advantages of studying algorithms. First, many problems faced by us have likely been addressed by other people. For example, most people would find the morning time very tight and would like an efficient routine. Good algorithms are likely documented, and when we study them and master them, we also gain the ability to solve similar problems. Second, developing a successful algorithm to solve a problem is the most convincing evidence for proving that we have understood the problem sufficiently. This is very important, especially when the problem comes to us with many unknown factors and complicated interactions among the involved factors. For example, consider the problem of stock price prediction. We roughly know that stock prices are affected by macro and microeconomics, politics, investor sentiments, etc. But no one can list all factors that affect stock prices. We also know that the interplay among these factors can be complicated, but no one can quantify them precisely. Imagine that if someone has developed an algorithm that can accurately predict stock prices, then the factors used by the algorithm and their quantitative model will be invaluable for us to understand stock price fluctuations. With all the advantages, let's now take a look at which topics will be included in this video series. In Module 0, we will give an overview of this video series, motivate the study of algorithms, and discuss the important components of algorithms. In Module 1, we will present several classical sorting algorithms. We hope the audience will get a high-level idea of what real algorithms look like and how we evaluate algorithms. In Module 2, we will try to introduce the theoretical foundation of algorithm analysis, including the basis for time complexity analysis and proof construction. In Modules 3 through 5, we will discuss three important algorithm design principles, namely greedy algorithms, divide and conquer algorithms, and dynamic programming algorithms. Each module will contain a set of algorithms developed under the corresponding principle. The algorithms can solve many important computational problems and are valuable themselves, and they can also provide us with a better understanding of the principles. In Modules 6 and 7, we will discuss algorithms for graph and strings. Graph and string are two important data structures, and there are many important algorithms developed for them. Some of these algorithms cannot be simply classified as greedy, divide and conquer, or dynamic programming algorithms, but we think they are worth some discussion. In Module 8, we will study the idea of tractability and reduction. We will give a very gentle introduction to the theory relating to P and NP problems. In modules 9 through 11, we will discuss ways to solve computationally intractable problems. All of them aim at developing algorithms that can run in a feasible time despite the intractability of the problems of interest. Finally, I would like to make some recommendations about textbooks. To clarify, I receive no money or other form of compensation from the authors or the publishers. I simply find these books useful for me to prepare this video series. Of course, there are other great books and materials you can look at. Okay, I'm showing the books I recommend here, and you can find the titles of the books and their authors. At last, thank you very much for watching this video, and I hope you will enjoy learning algorithms.